Are
Okay.
you gonna count that down, or are you just gonna?
I think we're starting up.
Yeah, here we go.
Yeah. Hi everybody. My name is Danby. I work with Autodesk Sustainability team, and I'm here with Jesse Harrington, who's a maker advocate who works on consumer stuff and lots of really cool things around the maker movement. And we've been actually working a little bit together this last summer on some stuff around sustainability in the maker space. We're really psyched to have all of you here. As part of what we do around sustainability, I run with some various other people, we run a site called the Autodesk Sustainability Workshop that teaches kind of the concepts and practice on how to do sustainable design, as well as how to use Autodesk tools to do things like be able to design things to be repaired, or how to design things to use the least amount of material, how to choose better kinds of materials, do green building, a bunch of things like that. And as we've been doing this, we see a lot of really interesting overlap with thinking about those kinds of things and what's happening in the emerging world of the makerspace. So I'm especially stoked to talk with you with Jesse. Both Jesse and I have backgrounds in industrial design, and I spent some time working as a woodworker and furniture designer, and Jesse's made all kinds of cool things. So we kind of have background in doing things hands-on, and it's really interesting kind of being able to close the loop and be able to talk about those things in the context of Autodesk and really in the context of tools that are a lot easier to pick up, that a lot more people have access to. So with that, I'm going to hand it to Jesse to talk a little bit about the maker movement and sustainability in general to start off.
Great, thanks, Dan. It's kind of funny whenever I get to meet people, they always say, what do you do at Autodesk? And I say maker advocate, and they're kind of like, yeah, can I talk to someone else? But usually, because they're just so confused as to what that means. So maker advocate is it's kind of this neat position, and I'll kind of go through my past a little bit and then tell you about what I'm doing now. But in the past, everything I was kind of working up to, I was like an illustrator for a long time, and then I started building this like bike-powered skateboard when I was in college just for fun, and it was called the Death Trap. And basically, it was hard to stand on, but it was fun to make, and it taught me how to weld, and it got a bunch of other people around me really excited to do things with their hands again. And we started welding. We made a series of like big wheel bikes, and it was kind of like this cool thing that we did, but we really didn't know what it was called, and we had no idea that it was part of this whole like movement of maker things that were going on in the country. And after that, I had the opportunity to kind of take what I learned there and to go to the University of Kosovo. And in Kosovo, I did just that. I taught a series of workshops on basically how to create bicycle-powered electricity. So I got to use my illustration side to make this completely graphical map of how to make a bicycle generator. And, ran a bunch of workshops with people that didn't speak the same language as I did. And they were able to see from that, how to create their own energy. And at the end of the workshop, as you can see in the bottom right, everyone got to like crank the bike and get the light to turn on. And it was kind of like, there's something magical there, and I really wasn't sure what it was. And it became very interesting to me. So I just kept kind of working in this vein, and it took me into working with museums. I started working at the Exploratorium to start making indestructible designs, things that kids can't break, but can also teach them a lot about how to build things or how to get involved with stuff.
That's really cool. I actually never heard that story, but I think it gets into a really interesting theme around how we use a lot of these kinds of tools for teaching about energy or teaching about materials or like getting people to understand that stuff. So that's awesome.
Yeah, it's gonna be. I mean, that's like kind of the whole background of tactile learning, right? Is there's a very large part of the population that really learns best by getting their hands onto something, and I don't think sustainability or even CAD software, for that matter. I mean, all of that it's so much easier for a lot of people to learn if it's hands-on and it's not, just spouting out of a book or just showing someone a demo. Which kind of leads me to how I got to this job. So after Exploratorium, Autodesk asked me to come over and work with a series of maker spaces, and at the time they're tech shops, and we'll talk a little bit about tech shop in a second, but work with people there that were interested in this whole thing called making, but really didn't have any CAD skills, probably had very little shop skills, and kind of help them tie those two things together. So I was able to, and I still am able to work. I work inside of a tech shop, which is a giant makerspace, and I get to, work with the software there and show people how to advance their designs through using the software. And I have two examples of that on the screen from Maker Faire this year. We got to use 123D Make to create a 12-foot tall cardboard Trojan horse, and it was all spectacle. I mean, spectacle, and there's a little bit of learning about architecture with corrugated cardboard and how to make something stand up like that with only using cardboard. So there's no skeleton under that. It's actually all just hot glue and duct tape and zip ties, and that's kind of how that stood up. And from there, I met the general manager of Tech Shop San Francisco. His name's Blaine Denlow. And Blaine's always been this old school shop guy, so he can do just about anything with his hands. And I'm on the other side where I can do just about anything with the software, but some of my hand skills just aren't totally there yet. And what we did is we got together, him and I and a group of 5 other people got together and built the car that's on the right side of the screen there. And what that was like we took 123D Make and kind of made our bulkheads with it, and then we also took Inventor and went through it and kind of figured out how much wire we were going to need, and figured out how we're going to bend stuff and what the bed raises were going to be and how much aluminum we're going to need. And then what Blaine found was an old Citroen CV chassis, completely took everything off it, and then we built the rest in by hand and put a BMW motor in. So the car there is sitting in front of the Henry Ford Center. And we actually got to meet the president of the Henry Ford Center, and he came out and was asking us about gas mileage and things like that. And it turns out the car gets about 65 miles to the gallon because it's extremely lightweight and extremely unsafe. There is absolutely no safety features in it, which is probably why it's so lightweight. But that gets better gas mileage than most of the cars on the road today. And it was just built by 5 guys that didn't really know anything about cars or anything about really what they were doing. But it runs, and it's kind of a nice showpiece to show what you can do when you have this perfect match of, CAD and real skill set experience.
Cool.
So on the Tech Shop, a lot of people ask what that is, and it's a makerspace. And the idea behind Tech Shop is if you give people access to CAD, tools, and machine shop full of tools, that it would be really interesting to see what they come up with and what they make. And so what Tech Shop is, it's 17,000 square feet of every tool you could possibly imagine. So it goes through welding, it goes through laser cutters, it goes through 3D printers, it goes into fabrics. I mean, really anything you could think of, Tech Shop has, and they have all of the Autodesk design software. And the extra part about Tech Shop that kind of makes it work a little bit more than other maker spaces or collaborative build spaces is that there's classes on all of the machines, but there's also people there walking around that can kind of help you build stuff. So when it's your first time on a mill, there's someone to come up to you and say, hey, it looks like it's your first time. Do you need a hand, or can I help you out by setting this stuff up? And it really does walk you through that process so that we're no longer hindering things like innovation because people are afraid of the machine. Now they're more excited and easier access. We're lowering the barrier of innovation, if you will.
Mm-hmm. And also getting a lot of people making things that and going into businesses. I think you're going to get into some of that too, right? Like that it's an amazing sort of incubator as well for business, for startups in clean tech and other kind of really cool projects that are getting made there.
Yeah, exactly. It is. Yeah, we're going to walk through a couple of these projects right now. Actually, of some of the businesses that were launched out of here. But it's interesting when we look at it from a sustainability standpoint, because there's kind of 2 sets of things that happen at Tech Shop that kind of match the sustainability need. There's individual projects that happen that have a sustainability need in their subject. Like, someone who's building something that's helping create sustainable practices. On the other side of it, there's places that launch that maybe aren't overly beach over the head looking like a sustainability or a green tech type of situation, but because they're using local manufacturing, they're actually cutting down very much on a large scale of the carbon footprint. Mm-hmm. That would normally be farmed out to overseas and then taken back through a bunch of box stores, where these people are selling at more of a local level. And then the third facet of that is the fact that we are now creating software that it really does help create faster digital prototyping and takes away from things like, I remember in design school, I'm sure Tom, you remember this too, like drawing hundreds and hundreds of pages of sketches only to keep one or two, and then moving on to that next phase. So it was just like so much paper and so much used goods and making prototypes. And now with the advances in digital prototyping and the software, I mean, we're seeing that stuff being cut down to, several PDFs in a slideshow and a 3D print or two. And it's pretty remarkable. So we'll get into that too in a little bit. So projects that are based on sustainability. This is a great project. This is Phil Hughes. He was a tech shop member. Phil, it's not like Phil came into this with no background. He has a bit of a background as an engineer. But because of what tech shop, which is just a makerspace, was able to offer him, he had ability to learn some of the software. So he actually used Inventor and the tools that were available to him at tech shop, and kind of rubbing elbows with those type of people. And what Phil created was this amazing cooling system for computer towers. And what happened is, I think, somewhere in the Silicon Valley, someone had a challenge, and they said, we're going to take 4 of the world's top leading cooling companies and Phil, and we're going to put them in a room together. We're going to test each one and see which one does the best job of cooling these towers. And Phil won by a landslide. And so now Phil has his own company that's gigantic, and they're the main supplier for places like Intel. And they're estimated to save the world X amount of water every year and X amount of power resources because of the way they're using their cooling towers, which is an amazing project. And then after that, here's another great example of on a different front. Ken Hawthorne is a lawyer, I think, pretty sure. And he really got into motorcycles a while ago, and then started in Tech Shop San Jose. And Ken's whole dream was to get this thing going on building electric motorcycles. So he was always into motorcycles, kind of, sick of the gas power thing. And he started building this electric motorcycle. And he now holds the world land speed record for electric bikes, and that's him out on the playa, out on this big flat, where he was just about to get the record for him. So everything from that, and then we have always the more artsy side of the maker movement. So this was an artist that was San Francisco based, but then moved to Detroit, bought an old schoolhouse, and he made this sculpture because, in Detroit, what do you have more of? You have a bunch of recycled cars and abandoned cars, car parts laying around. So this is a dragon. It's an art car, so it has actually a DJ booth kind of on the upper and the back slope there. It breathes fire. All the legs are made out of recycled tires. All the head is made out of recycled car body. And then actually, even into the electric panels, a lot of that's made using recycled wire they took from cars. And it's pretty impressive to look at, and it's kind of automated. The tail swings back and forth, and everyone can ride on it. But it just shows, if an artist has that type of the accessibility to some of these things, what they can typically create is pretty impressive. Okay, so that's makerspaces, and how many makerspaces are there? So right now there's at least 500 plus individuals in the U.S. alone that we know about that are registered on makerspaces.com. And they're not all like tech shops. I mean, some makerspaces are places where people get together and it's usually a closed amount of people, so there's 20 to 30 people in a room, but they're kind of sharing ideas and sharing, they form this like glob of information, and some people have certain skill sets that others don't have, and just like Blaine and I, they're able to come out with amazing things from those. And so if you don't have one of those in your area, what do you do? There's this other program called 100K Garages. 100K Garages is a cool website that if you ever need to find something like a laser cutter or a shop bot, it's out there for you. So you check on there and you see what's in your local area. You can see how close a shop bot or a laser cutter is to you. That way you don't have to worry about going and buying your own and having, everyone doesn't need to have their own equipment. There are spaces out there and there's communities out there to help everyone build. And then globally on the side, there's also Fab Labs, which are in 24 countries around the globe, and there's even more than that registered right currently. But it is all over the world. This isn't just a U.S.-centric movement, and it's not just people that have extra time on their hands. I mean, this is something that's being very widespread and used. Okay, so an example of people that are building something that don't kind of hit you over the head with sustainability, but are building locally in manufacturing. This guy's Patrick Buckley. You can see he went to MIT. He was a mechanical engineer there. And he came to Tech Shop Menlo Park and had this idea for an iPad case. And it was just when the iPad came out, so it wasn't like it is now, where there's just like such a flooded market of these things. So Patrick, we taught him, he learned how to use Inventor. Then he also learned how to use a ShopBot, which is a CNC router. And basically, you're basically hitting a print button at the end of the day, and it's kind of cutting out this form for you. Patrick also got really into bookbinding, and it turns out that there was a bookbinding manufacturer in San Francisco that was about to shut down. There was only 3 employees left, and they were about to close the doors. Patrick started taking off with this design, so he took over the factory and he's now hired his 33rd employee. So he's saving jobs. It's also just a remarkable little product, and it's built out of bamboo on the sides there, and it's a hand-bound book. And he's gotten so popular that guy has one. So there's a bunch of photos with Obama holding his dodo case. And he's also now in J.Crew and has a private line through J.Crew where he offers it. And that's all manufactured locally in San Francisco. So it's not something that has to be shipped overseas and then shipped back. It's all kind of like local resourced goods. And Patrick's pretty involved in the local San Francisco community. And another great example of that, and this guy's on the other side of it, this guy's on the very startup side of this, is Ryan with Wasabi. Mm-hmm. And Wasabi is just a headlamp, simple little headlamp, but he injection molds all of it in Tech Shop San Francisco because he knows the demand for this product isn't going to go into the hundreds of thousands. It's going to go into the possibly thousands, and he's really looking forward to that. So he actually runs the injection molder in San Francisco. He creates what that piece is in the middle is actually the packaging that the product comes in, folds into this lantern, and then you can hang it from the inside of your tent. So he's using sustainability in packaging as well as locally based, and he only injection molds as many as he needs for that week. So there's never like this big overrun of injection molded parts that are just going to be sitting around a warehouse if he needs to design change or if he needs to change the mold. Pretty remarkable, and it charges by solar. It charges by actually the strap. You can tug on it; it'll do a tug charge on that one, and then it also charges by normal means of kind of plugging it into a wall socket. Mm-hmm. But the light lasts about 8 hours, which is kind of unheard of for a headlight. So these are some of the softwares that we have out there right now that are available to just anyone. And Autodesk kind of is on this mission right now, especially the consumer group, to get products out there to let anybody be like these people and anyone to, that is inspired to create, to be able to create things in a great manner. So in a free manner as well. So some of the products here on the Imagine side, so we can now sketch, like I was talking about earlier, with things like Sketchbook Pro or Sketchbook Ink. We can also, you don't have to be a CAD person anymore. Like you can just use a product like 123D Catch, where you're going out and taking a bunch of photos of something, and it's creating a 3D model for you. Use a product like Sculpt, where it's already starting with inherent forms, and you're just kind of sculpting it out. And same as 123D. There's a product there that it's free CAD software, it's free parametric CAD software. So you're using that, and there's so many pre-made forms on the website and pre-made things out there through things like Thingiverse. So it's never starting from scratch anymore, which I think is one of the most intimidating things for new creators. And this is, so they're great tools for that. And then if we move over to the right, on the Create side, you can 3D print from most of those programs, or you can take it into this program called 123D Make, which is that rocket ship symbol under Create. And what that does is it actually takes any solid model and it slices it up for you into laser cuttable or shot-bottable files. So no longer do you have to be like intimidated about how to run some crazy CAM program. You can actually just bring it in, It takes a PDF out, so you can use that PDF to laser cut with, so you can make extremely fast prototypes that are, deadly accurate. So we've done a lot of like couches that way, or if I'm doing a lamp or something like that, I just want to see what the form looks like. I can get that form out like in under an hour usually. I just be able to see that before I move forward. Great. And here's a little preview of some of the things that you can do with Sketchbook, and from a traditional product design, moving over into the maker stuff. It's pretty interesting to see. It really does run the gamut of if you're a maker and you're trying to become an entrepreneur and you need to sell that idea to someone. It's one of the best ways you can do it. It's kind of like be able to sketch something out in Sketchbook and change it really quick and be able to give it to them. This is without going design school for years. This is just learned it on your iPad, and just have that initial spark of being able to, really show somebody what you're thinking about without having to try to explain it to them, with a bar napkin or something like that.
Mm-hmm. Cool, thanks, Jesse. I'm gonna dive in and talk a little bit about some of the stuff that we did this summer with an intern who actually worked with me, but also with Jesse, because he was based over at Tech Shop all the time, all summer long. He had actually super jealous of him. He had the best internship ever. So his name was Ben Chapman. You'll see some pictures of him in a minute. And some of the things that he came from Olin College, which is a small engineering school out near, kind of in the Boston area, and has a lot of experience doing maker projects of different kinds, just making all kinds of things and hacking all kinds of things. And we could talk about Ben's projects at length, but I'll show you a few of the ones that he worked on this summer, and also kind of thematically some of the things that he was exploring around using, being based at Tech Shop, so having access to all these tools, using some of the simpler tools that we've got that Jesse just talked about, even though he had a background using more advanced tools like Inventor for doing CAD models. So he was using really simple tools. He was prototyping and building everything at Tech Shop, and then sharing stuff out on Instructables. So all these projects that I'm going to talk about are all on Instructables, and you can get all the details and download the design files and that kind of thing. And some of the opportunities he identified are the ones that are just up on the slide right now around, how do you think about sustainability when the kinds of things you're making are actually small, they're kind of limited run. It's a different set of questions, although it's related to the kinds of questions that an industrial designer or mechanical engineer would have. You're still making objects, and so you're still thinking about things like materials, energy, water, toxicity. Those are all the same kinds of considerations, but you're not necessarily, at the maker stage looking at volume. What happens if I make 100,000 of these things?
Just to jump in on that,
yeah.
I think Ben makes a really beautiful point here too. It's beautiful, lasting things, but it tends to be that when you start to actually manufacture things yourself, or when you actually start to get your hands-on experience, you start to really realize what materials are and where they come from and what they do to you when you use them. And I think that also is just like, it's so important. I've never met a maker that wasn't, extremely cautious of using things like acrylic or things like that are a little bit less on the recycling side, or something that, a little bit more toxic. So it's pretty interesting. And I think he makes some really keen observations there.
Yeah, so I'll just going through some of these things. I mean, making things that last and that are beautiful. Certainly it's something you see when people are building things in a custom level, whether they're amateurs or they're making, custom one-off furniture, for example. But it also means that you're really focusing energy on something that will last, and doesn't mean it means avoiding a lot of waste and having to buy things over and over or having things break down. We look a lot at generating energy and clean water. So looking at clean tech, both from the standpoint of, how can makers be innovators in creating new clean technologies or energy saving or water saving technologies, but also to teach about those ideas. Because again, by getting your hands on these things, by building solar technology at a small scale, you start to understand how energy works, which I think is really cool. There's certainly things that use less energy or water. As I mentioned, teaching environmental literacy. There's a lot of projects where we see people making things from waste, either to make a point, for an aesthetic reason, or just because you've got available materials. And and it gives you an opportunity to actually use the materials that you've got. Lots of really great projects. Actually, I think there's an Instructables competition right now on fixing things, but we're really interested in how you can modify or hack or repair things. That was a big focus of Ben's work this summer. We certainly looked at material considerations. So how do you choose the least impactful material, which you can do when you're looking at wood? Are you using an FSC certified wood, or are you just buying whatever wood? Are you using things that are going to cause you to inhale fumes or not? And we also looked at biodegradability. Can you go to the next slide? We're doing this from across the country. I'm in San Francisco, and Jesse is in New York. He was there for Maker Faire. So this is Ben, and one of the first projects that he worked on was around teaching clean energy. And so he made this parabolic solar water heater and bacon cooker. There's a great video of it on his Instructable online, and he did this by using a whole bunch of things: 123D Make. He laser cut parts of it. Just go to the next slide. This is a picture of him cooking bacon. And this was really, in a lot of ways intended as a project to teach concepts of how much energy does it take to be able to heat water or to cook things. So functionally, it does a certain amount. There are a lot of different kinds of parabolic systems like this. So you'll see, cookers and water heaters all over the world that use these kinds of principles of concentrating energy into a parabola and being able to really use that energy to do something or to do some kind of work. So he did some really interesting work with that. You want to go to the next slide? And he modeled the whole thing in 123D Make and then fit all the pieces together using the laser cutter, as well as, this was a question. One of the conversations that we had was, one thing he'd used a lot of was epoxy. And I was kind of like, well, what other materials could we use aside from epoxy to do the same thing, given that pretty much every epoxy has fumes. It either has bisphenol A or formaldehyde or whatever, and a lot of the time sometimes you can't avoid that, but a lot of the time you can. So we were looking at using different kinds of acrylic paints and that kind of thing to do the same kind of thing. So again, you can look up this project and get the design files on Instructables. You want to go to the next slide? And just a few pictures of the 123D Make interface that he was using.
Yeah, and actually the funniest thing, and the thing to be aware of if anybody actually wants to build one of these, is Ben would sit this around our office, and then the sun would come out, and we have these giant windows on all sides of our office. And every once in a while we'd start smelling something, and we noticed that the mirror was kind of focused on something that was not what it was supposed to be focused on. So. Word to the wise. Yeah,
this is why you don't leave. It's why you don't leave your solar parabola in the middle of areas where there's a risk of forest fire. But anyway, yeah. Keep going. He did a project on upcycling. So upcycling is the concept of taking something and being able to modify it and use it for another purpose. So it's also used sometimes around materials. Downcycling means that you're taking something and recycling it into a less productive material. Upcycling means you're kind of using it for something even more productive. So one of the things he was looking at was the principle that a mug, most of the time mugs have an area of unglazed ceramic on the bottom, and you can use that unglazed ceramic to sharpen a knife. And so he created this structure, kind of like a hack onto the bottom of a standard ceramic mug that will work to, keep the mug in use, but also really, more importantly, probably is keeping your knives super sharp and working really well. So this is just a first pass at looking at 3D printing. He was also looking, this really got us into a whole exploration of 3D printing and kind of where it functionally can work. And really testing out different kinds of materials. And so a lot of the things that he worked with, he found, that using PLA, which is a corn-based plastic, worked pretty well. This is actually a PLA-based print. You want to go to the next slide? And the one thing I'll say about PLA is that it is compostable under the right conditions, right? So if you have a green bin available in your city, then that's the kind of place where you can actually compost things, because you need to have a certain amount of heat to be able to break down all that polymer. So you can't really toss it in. You wouldn't really be able to toss this into your garden compost and have it break down unless it was really big. But in any case, this was a first pass at looking at how you can extend the lifetime of existing product, look at upcycling, and explore kind of the strength capabilities of something like PLA and 3D printing.
Yeah, and I think he hits at another great point here too, where this is sort of the lifeblood of the maker movement, right? Is everybody has this like bin wall, or everybody like hoards a little bit at least of things that normal people would throw away. So what Ben saw here was a mug that was probably going to end up at a Salvation Army or Goodwill, which is fine because it's going to be reused. But at the same time, he's kind of looking at what can I do with this that's a little bit more purposeful. And I think that's great. And it's such like the heartbeat of what this movement's about, is kind of like finding that thing that would normally be junk to somebody else and recreating it and making that better life for it, or at least different life.
Yeah, and we're super interested in functional uses of 3D printing. That was really one of the things he was also exploring as well. Do you want to do the next slide? So on that same theme, one of the things that one of the first projects he also worked on was looking at repair. And so this is a bike mount. You can see that little blue piece in the middle is the mount part, and that's a 3D printed part. Sometimes those things break, sometimes they're lost. And so we were exploring possibilities of what happens when all of a sudden this object that you've got that may have a lot of function remaining in it, certainly has a lot of embodied energy and materials in it, still has a useful life ahead, but it breaks down because of this one part that breaks, or this one part that gets lost. So this is an area where actually we're really interested in 3D printing. It doesn't work in all conditions because of where we're at in terms of 3D printing technology. So not all 3D printed parts will work to do just what I described, but we were surprised at actually how much they could do. So he actually modeled this up using 123D. Because it's precision, he really needed to go in there and measure the parts using calipers and that kind of thing. But he tested different parts in on different printers. So he used 3 different printers, 4 different kinds of materials: the MakerBot, the Type A, the Object Printer, using things like ABS, which is pretty standard, the PLA, which is the polylactic acid plastic that I was talking about before, it's corn-based, as well as the Object Printer, which is a much higher resolution, more expensive print. So we're also looking at cost. These higher resolution, fancier printers, it costs more per gram. But we were surprised actually that the PLA held up as well as it did. So it did take some tweaking to get this to work ideally, but it was pretty interesting kind of seeing what the limitations are. And I'm actually encouraged by some of the research that I'm seeing emerging in 3D printing, where on one hand you're seeing a lot of more access to ABS plastic and people making small plastic components. At the same time, there's a lot of really interesting research at places like, at University of Washington in Seattle. There's a group called the Open 3DP who are doing all sorts of research on bio-based materials, or printing in salt, or printing in cookie dough, and lots of different things like that. So I think we're still just on the edge of being able to see what printing can do.
Yeah, and coming right out from Maker Faire, and actually I was just hanging out with the guys from Shapeways yesterday, which is a 3D printing resource online, and it seems like on a daily basis they are looking at those things and kind of saying, okay, well, what can we print with next that's going to make this stronger, more durable, what's going to make it last longer, what's going to make it not influx with the heat, and also keep the cost down to a point where people can actually start using these things and reusing them. Yeah. And what's been amazing is only being kind of tracking this stuff for the last 3 years, the leaps and bounds that have been happening, just in the last 6 months of the amount of 3D printers. There was at least 15 different 3D printing companies at Maker Faire this year, all with a slightly different variation on how to do it. Some using even different materials that I never would have thought about.
Mm-hmm. Yeah, so let's keep going, because I want to make sure we have some time for questions. So this actually was a neat project. He was also using 3D printing, also by Ben Chapman. looking at how you can hack a kite to generate electricity while you fly it. So basically what you're looking at here is a store-bought kite with a whole mechanism that been attached to it that has motors, 3D printed mounts for the motors, as well as strips of LEDs. So let's go to the next slide. And so this also was really interested in because, again, he's prototyping and working on creating functional parts using 3D printing. So again, he's using 123D and printing them with PLA. And a lot of this project, from a functional perspective, can charge a battery for an iPhone. It can light up the strip of LEDs. All really great, mostly from the perspective of being able to teach the concepts of clean energy and teach energy literacy. How much energy does it really take having something aloft to be able to charge an iPhone battery, for example? And so that's some of the stuff that we were playing with as well, is like trying to develop projects that you can use to teach these concepts to students, for example.
Sure.
Yeah. So next slide. Yeah. So with that, those are the main projects that we worked on. Again, I suggest taking a look at those on Instructables. It's just ben.chapman. You can see all the details, all the commentary, and he is an engineer, so he gets into the details of how he does some of the calculations at the beginning as well to think through how some of these projects would work. But I think what's wonderful is there's lots of great pictures. And before we go to questions, just a couple things that I suggest you take a look at. You can reach either of us. Both our emails are up there on the screen. The site that I run is called the Sustainability Workshop. So that's sustainabilityworkshop.autodesk.com. And so there's tons of materials on there. If you're interested in the makerspace, there's a lot of things that look at the environmental considerations, looking at materials and energy, for example, and teaching some of those concepts. So if you're unfamiliar with those, or if you know students who are unfamiliar with those things, this is actually a great resource for teaching these kinds of ideas. There's also a blog there's actually a blog post that Ben wrote on 3D printing and some of the experiences he has, so you can check that out as well. And then Jesse's got various maker resources that his team is representing, like Instructables, 123dapp.com. And I do want to mention that we are currently about to launch an Instructables design competition. So this is actually on Instructables right now, open for entries on October 29th. And so that's a broader design competition, but there is a sustainability workshop prize if you've got a really cool project that you want to put up on Instructables.
And if you've never done an Instructables competition before, I mean, it is fun. So not only do you get to make a cool project and put it up there, but you get all sorts of crazy people writing in and telling you about how cool your project is. Mm-hmm. So I mean, if you've never done it before, I think it's a life changer.
Excellent. So with that, I think we are opening it up to questions. So if you have a question, I think that there's a means that you can type it in. And we have somebody on the line with us who's going to help us out with that.
Great.
Yeah.
We have one question that came in about choosing the best materials for what they're making. So how do we guide people to choose the best material?
Right.
They're making?
Yeah, it's a really good question. It's a very broad question. And Jesse, I'll let you answer that as well. When it comes to things like wood, I think that one of the things that I look out for, just having been a woodworker, is things that are FSC certified. So that's the Forest Stewardship Council. So there's various things where you can find plywood and things like that are FSC certified. That's really ideal because that basically means that wood, for example, is coming through really sustainable forestry management practices. And just as a general rule, I mean, I think that you can also research the use of a lot of tropical woods. You can just go in and buy them, but that doesn't necessarily mean that they're a really good choice in terms of environmental impact. So taking a look at, being careful when you buy things like ebony or really expensive things. There's a couple ways of looking at that. One is, a lot of the time you're making something for the first time, and you should be careful, with where you make your first cuts. I think being really careful about those kinds of use of really valuable materials is important, and I think you can research a lot of that stuff as well. When it comes to plastics and polymers. It can be tricky. I mean, I think that there are a few things. Most of you, if you're living in places where there's community recycling, you'll find that you can't most of the time, unless there's a market for it in your region. It's hard to recycle materials or recycle plastics. But that said, I think if you're able to be really careful about which ones you're using and you're able to do some research, it's harder with plastics because there's so many of them. I mean, I think
and on the plastic side too. I mean, if somebody wants a cool idea for their Instructables design competition, there's so many times when you're 3D printing, especially on the consumer level, with like a MakerBot or something like that, where the print errors. And even though PLA is it's a nice plastic, it's made of corn, it'd be great if someone made a way to cut that up and put it back into the machine. Things like that are really important. And then on the other side, with like the wood that you were talking about, I always find whatever scrap place there is around. Like in San Francisco, we're kind of blessed to have things like urban ore or scrap. In other cities, there's definitely been other resources out there. And when you can, I always think get reclaimed wood, or go find it somewhere and clean it up. It kind of adds a bit more personality to it anyway. And so when that's a possibility, I mean, I would say definitely go for that.
Yeah, it's really true. I mean, a lot of this stuff, there's, in terms of general things, you can actually research stuff online. We've done a bunch of work, building analysis into our tools, into our, professional software around being able to look at materials impacts and looking at carbon impact and things like that. So we've got a thing called the Eco Materials Advisor and Inventor. So for those of you who are, more advanced users, you might want to take a look at that. But generally, if you're just sourcing locally and looking at kind of how to make particular kinds of decisions, the web will help you out pretty significantly. We don't have a kind of a central database for this, but there's a lot more information out there than there used to be. And I think it's always worth being just careful about what you're inhaling. Even tropical woods can cause you to break out. So it's worth just being really careful about how, as soon as you start sanding things or cutting things up, as Jesse mentioned, you're going to be start thinking about what's the impact on this? What am I breathing?
Yeah.
And it's fairly easy to find that information online. Yeah.
So the other question I got was that there's no tech shop or makerspace near some of these folks. So what tools do we recommend they use if they don't have a tech shop or makerspace near them?
Yeah, so I was kind of mentioning that 100K garages. If that's a possibility near you, check the 100kgaragesite.com. They're run by Chapman, who's a CNC router company. But what they did is they find all those people that own shopbots or laser cutters or 3D printers, and they all registered on the site. And so we can pretty much pinpoint, one of those things that's closest to you to get into. And if you're just at-home manufacturing, one of the nicer things about being a maker or being into this sort of stuff is creating your own. So I know a lot of people that have made their own CNC routers just by using 80/20 and then ordering some of the other parts that you need. But a typical Fab Lab startup is usually some sort of consumer-grade 3D printer, like a MakerBot or a Type A machine, and then some sort of CNC router, something like ShopBot makes a desktop version. If you don't want to build your own, there's that out there. And they're not the cheapest things, but if you do that, I would say start your own makerspace to do it, or start your own Fab Lab and get other people involved and have them help you. That's how Tech Shop was created, and that's kind of like the, again, kind of like the lifeblood of this whole maker community is you're only as good as the people around you, so you should try to bring those people in to create those resources in your community because they are important, and people, it can definitely change your community in a very positive way.
Mm-hmm. Yeah, absolutely.
That's great. So that was all I had that came in online.
Okay, thank you so much. Well, if you guys have any more questions, give us a shout. You can actually ask questions on Twitter. Just send me a note at Eco Workshop, and I'll respond over there. Or you can send us emails. Our emails are up on the screen. And thank you so much. Thanks so much to Jesse calling in from a weekend at Maker Faire. And thanks so much for taking out some time of your day to hang out with us. We really appreciate it.
Yeah, thank you guys so much for having me. It's been incredible, and it's something that's very near and dear to my heart. So I'd love to see these conversations keep happening.
Totally. Yeah, okay, cool. Go make stuff. We'll talk to you soon.